So we come back to our Puredata exercise. So in last exercise, we have tried to use the pix movement and the pix block for very simple motion detection. So we make use of the frame difference between the current frames and the last frame in order to make sense of the movement, which is across the screen or moving vertically or horizontally. So in this exercise, we try to improve the version such that we can have a relatively smooth movement of the object instead of very jerky movement from left to right or from top to bottom. So let's have a very short review of what we have done in the last exercise. So we create the screen with a dimension 800 by 600, and on top of the screen we play a full screen video which occupies the whole window, and within the video we try to find out the movement. So that is the difference between the current frame and the last frame, and after taking the alpha channel where the movement information will be stored in the alpha channel, we make use of the block tracking to select information from the alpha channel. So after that, the X and Y information of the moving part will be fed to another jam head operation. So this is the display of a rectangle, a very tiny one, and we use the X and Y of the block movement to control the translation of the X and Y coordinate. So let's continue. So in order to have a more visible form of the rectangle, we try to change the color. So many weeks ago, we have made use of the objects like color or color RGB in order to change the color of a geometrical shape. For the color object, we need to use, for example, a list of 3 numbers, and this list is come with the message. So we use, for example, 100, which is the primary color, red. And after that, we disconnect the link between the X and Y block tracking and also the translate value of the X and Y coordinate. In order to have a better presentation, we will make use of this send and receive over here. So we would like to receive the X value through these objects. And for the Y one, we duplicate one for the receive Y. So the R is actually the short form of the receive object, and similarly, S will be the short form for the send, which we're going to use over here. So instead of just putting and send and receive and connecting them together, we'll try to have a look of a new command. So the name of this command we call the smooth. Both for the X and the Y value, we try to insert this particular smooth command between the value we send out from the block tracking and also the translation value. So if we take a look of the smooth command in the help, it actually is an example where you can try to make use of your Y mouse position in order to plot the graph. So the meaning of the smooth command is try to have a smoothing out. It's a kind of running average of the value which we use it as an input, and then we'll use it to smoothen the overall value and then to have a more smooth or less jerky value for those output. And with the second inlet, we're going to supply another number, and that number will control the magnitude or the strength of the smoothing operation. And for this one, we will use, similar to most of the example, a horizontal slider with the value between 0 and 1. And both of them will apply to the X and the Y's for the smoothing. So after we complete the smooth command, we try to send out those values to the X and Y of the translate command. So we finish it with the send X and the send Y command. For send and receive, the key point is the S and R, the send and receive. So the label after that is an indicator where you can use any arbitrary name. But for the sake of legibility, usually you have some indicator or label which is meaningful to your patch. So after we finish this one, we try to have a look at the effect. So we select to create a window of this dimension 800 by 600. And then we start the rendering. And make sure you also select this one, which is the alpha channel, and also some initial setting of the pixel movement. Again, you can also select the color value for the rectangular block. So the next step, what we are going to do is to have some value or initial value for the smoothing command. So let's start from the middle. And then we do some testing on the screen. What I'm going to use is I try to stick out this pen and then try to move it around. So this is kind of the default operation. You use the moving object in order to control a virtual object on the screen. And then the next step is we can play around with the parameter of the smooth command. We move it towards the left hand side, that is the value closer to 0. And we use this pen as an experiment. You can see the obvious change in the speed of the tracking. So actually the tracking is the same, but the way that red rectangle or square follow the pen will be quite different in a very obvious way. So this is the value close to 0. And then we try to push it towards the right margin. So this is a value close to 1. And then we do the testing again. So you can see this little bit more jaggy, which is similar to the case when you are without the smooth command. So it depends on your operation, how you would like to use your virtual object to follow the movement of the real objects. So those are the design criteria you may look into before you try to put an initial value for this particular slider. So again, you can also put it over there, and then according to the actual lighting condition, you try to manipulate the slider either in the pitch movement and also in the smooth command in order to achieve the optimal result of tracking according to your design. So this part is an enhancement of the last exercise. Basically, we'll make use of the smooth command to smoothen some of the jerky behavior of those values we install or we put it in the X and Y for the block tracking. And then subsequently, we use it for the translation of that particular graphical object that's an rectangle over here.